Welcome to Ask and Learn.
In this question, we are asked to prove that this statement, I will call it P of n, is true for any non-negative integer. So it starts with 0, 1, 2, and so on. So we use math induction, obviously. But when we include 0, because they say non-negative integers, we have to start basic step at 0. At 0, not 1 right now. But it's the same principle. It doesn't change any of the details. We have to do it. First, basic step. So n equals 0, it will give this statement 1 minus 7 over 4, which is 8 over 4, which is 2. So we can see that basic step is true for n equals 0. Now, assume that the statement is true for some n, then we want to show that it's true for the next, so n plus 1. The Pn give us this equation, and we have to work with this to get to the next statement. So what I'm gonna do is I'm gonna add 2 times minus 7 times to the n plus 1, because this is the next terms that will appear on the left hand side, right? So we are done with one of the side already, because now it's gonna end with the term that we want, 2 times minus 7 to the n plus 1. And now we just have to rearrange the right hand side to get what we want. It will start off like this, right? This we want to get, I will move to the next. We want to get to the just add this power to it. That's all we really need. And luckily in this case is quite simple, because we can just add it like we adding fraction. 2 times 4 will be 8 now, right? And denominator will go across everything. When we do this, we can see that minus 1 and plus 8 together will be plus 7, right? Of that term, the same term, over 4. But plus 7 is, we can read as minus 1 times minus 7, right? It's the same. So we now have the new minus 7 for us to use. So we times minus 7 to the last term and get n plus 2, leaving minus 1 behind. So this is all just rearranging things. Now we go back, and you will see that this is exactly the right hand side of the n plus 1 statement that we want. We start with the assumption and we end up with the new statement, the n plus 1 statement. So our inductive step is finished. So by math induction, it means we have proved the statement. And that is how you do it. Thank you.